All right, last I left you, we had filled in the top half of this transformations handout, and now we're going to fill in the last 3 graphs for some other transformations. Let's head over to Desmos, to the second Desmos link that I posted on Blackboard. All right, so this file is called Transformations Multiplying. So we did everything we could with adding and subtracting, and now we're going to multiply. And you can either multiply by a -1, or you can multiply by a different number than -1. So let's talk about -1 first. All right, so here's our square root of x graph. That's our dotted line graph that we're familiar with. All right, so if I put a negative on the outside, we get a reflection. It looks like I grabbed the x-axis and kind of rotated the whole graph upside down 180 degrees. All right, so we call this a reflection. You can call it a flip. All right, and it happened kind of in a vertical way. Remember when we were adding or subtracting on the outside, that moved things up and down? So when you multiply on the outside, it's going to have a vertical effect on the graph. Okay, so this top half of the graph, the only half of the graph, flipped upside down underneath the x-axis. Right, so it's a vertical reflection. All right, so we multiplied on the outside of the function by -1. So we're going to say the graph of negative f of x is the graph of f of x reflected vertically, or vertically reflected. So that's one way to describe it. You could also use the word flipped, or we could say it was flipped over the x-axis. Okay, whichever way makes more sense to you, so you can remember it that way, then use either terminology. It's fine by me. All right, next up, we're going to multiply by -1 on the inside of a function. And at first, this looks kind of crazy. Like, so I have square root of x, and then the next thing I have typed in there is the square root of -x. And I just kind of beat you with a stick that said, don't ever take the square root of a negative number. But let's turn it on and see what it looks like. All right, well, that kind of made a bird. But look, it took the square root of x graph and flipped it over the y-axis. Look at where that green graph is. It's got negative x values in its domain. So it likes the numbers -1, -2, -3, -4, because when I plug those numbers in for x, on the green graph, I get square root of -4. So those negatives cancel out and actually give you the square root of a positive number. All right, so this is why this graph lives over the negative x-axis. All right, and again, moving that transformation inside the function affected a horizontal change. So this is a reflection, just like the first one, but it's a reflection horizontally. So our second to last rule is f of -x. Okay, so now I've moved the -1 on the inside. It's still a reflection, but this time it's a horizontal reflection. So horizontally reflected. You could say horizontally flipped, okay, or we could just say it's been flipped or reflected over the y-axis. All right, we got one more transformation to go. All right, last thing we're going to do, we're still doing multiplication. We're going to multiply by a positive number on the outside of the function. So I'm going to turn on my cube root of x graph. And I'm going to multiply that by a number. And let's say I'm going to multiply by 3. Okay, so I'm going to multiply by 3. I need my cube root of x. All right, and what in the world did that do? All right, so let's think about what this might be doing. Okay, so my y value in the black dotted graph, y equals the cube root of x. So what I've done when I multiply it by 3 is I have tripled that function. I've tripled the y coordinates. Okay, so all the values that are on the right, they all got taller. Okay, so you can see I've got like the point 1, 1 on the graph of cube root of x. And it's hard to get right on. There it is, 1, 1. And now that y coordinate has been tripled. So on the green graph, you've got 1, 3. Same x coordinate, triple the y coordinate. 1, oh, there it went, 1, 3, there we see it. Okay, and then like we have the point 8, 2 over here on the cube root graph, and we have 2 times 3 gives me 8, 6. So the same x coordinate, but triple the y coordinate, because we've just taken all the y coordinates and made them bigger. Okay, so something else can happen though when you're doing multiplication. You could pick a number that is smaller than 1. Okay, so instead of 3, let's say I had multiplied by 0.5. All right. So that still took all the y coordinates and multiplied them by the number 0.5, but that visually has an effect of making this thing shorter. Okay, so it's shrinking the y coordinates, cutting them in half. All right, so this is going to be a vertical either stretch or shrink, depending upon what kind of number that you multiply by. If it helps you to remember which one does which, think about multiplying your paycheck by a number. If you multiply your paycheck by 3, it's going to stretch it. If you multiply your paycheck by 0.5, it's going to shrink it. All right, so our last transformation is going to be multiplying by a number. So I'm going to say a times f of x, and we're doing this on the outside. And this is going to be the graph of the f of x vertically shrunk or stretched. Okay, so it's going to be vertically, let's say stretched first. And that happened when a was a big number, right? Stretching your paycheck with a big number, or vertically shrunk. And that's going to be a number that's less than 1. And I'm going to say that it's between 0 and 1. We know that if the number gets negative, that's going to affect a flip. Okay, so vertically stretched or vertically shrunk, essentially all you're doing is you're multiplying the y coordinates by a. Whatever that value of a is. All right, so it is possible also to have horizontal stretches and shrinks. These get horribly convoluted with horizontal flips and horizontal shifts. So we're going to save learning about those until a little bit later when we need to talk about them in trigonometry. So right now, these are all of the transformations that we need to worry about. All right, the last thing I want to do is run through a few quick examples. We're going to take some functions and try to predict what the graph would look like. And you can always go check these on Desmos to see if I'm right. All right, so I've given us the function x cubed minus 5. You may want to have your transformation handout handy. This one is going to be a transformation of the graph of x cubed, and I'm going to do a quick sketch of this. This is not like a beautiful sketch. X cubed was that snake-like shape, okay? Our x cubed graph. Subtracting on the outside is going to affect a vertical change. So this is going to take my graph down 5 units. So I'm going to pick up that x cubed shape. Instead of going through the origin with the flat bit, I'm going to be down here at -5 with the same exact shape. Next up, f of x equals the cube root of x minus 7. So this is going to start off with the graph of the cube root of x. So I'm going to draw my cube root of x graph. Again, I'm doing really quick sketches here. That was the kind of flat square root shape that had the left-hand side to it. And I've subtracted 7, but I've subtracted 7 inside, which means a horizontal shift. So horizontal shifts go backwards of what we think. So this is going to take me to the right 7 units. Okay, it's right instead of down because we're doing it on the inside. So I'm going to say instead of having that sort of flat bit for the cube root graph at 0, I'm going to shift 7 to the right. All right, so here I have 2 things going on. I've got x plus 1 squared plus 4. All right, so we're going to start off with the graph of x squared. Okay, rough sketch of x squared. There's my parabola. All right, so the plus 4 is on the outside. That means I'm going to move the graph up 4. The plus 1 on the inside means a horizontal shift. Adding, go opposite of what you think. So we're going to go to the left. So left 4. Left 4, left 1. All right, so we're going to go up 4 tick marks and left 1. So I'm going to go up 1, 2, 3, 4, and to the left 1 tick mark. And that's where that bottom of the parabola is going to move. And it doesn't really matter if I go left and then up, or if I go up and then left, it's going to be the same thing. Okay, just a rough sketch to get an idea of where things are going. All right, last one we're going to look at, -3 times the square root of x. All right, so it doesn't look like it, but we've actually got 2 transformations going on here. So this is kind of like -1 times 3 times the square root of x. So the 3, remember multiplying your paycheck by 3 would stretch it. This is going to be a vertical stretch. We're going to multiply all those y coordinates by 3, and then that negative is going to be a vertical flip because we're multiplying by negative on the outside. Okay, so we're going to have a vertical flip. All right, so we're going to start out with the square root of x graph. Again, doing a rough sketch here. There's my square root of x graph. All right, so we're going to flip it vertically. It's going to be hanging down below the x-axis there, and then I'm going to stretch it, make it taller by a factor of 3. Okay, so when I flip it upside down, and I'm going to make it taller by a factor of 3. Okay, and that's a rough sketch. Notice that I didn't move the point at 0. When you have a y coordinate of 0 and you triple it, you're still at 0, right? If your paycheck is 0 and you stretch it by multiplying by 3, you still have no money. All right, so that should get you through your homework that is due on Wednesday, and I'll see you in class then.